All right, continuing in our trig unit, today we're going to talk about the sine law. The sine law is useful because it can help you figure out any triangle. Before, the trig ratios you did, like tan theta equals opposite over adjacent, that stuff was only for right angle triangles. It's still useful for some word problems, but the sine law opens up a lot more possibilities. So the sine law is written right here. You can have it with sine A over little a, or you can have it the little a over sine A. Just so you know, usually when you do capital letters, it's an angle, and when you do the lowercase letters, it's a side. This is going to be really important to understand so you don't mix up the numbers and where you put them in the equation. The other way to remember is the letter that's next to the sine is obviously an angle, whatever you got to do to remember. I have an example triangle written right here. What you're going to notice is that side A is opposite from angle A, side B is opposite from angle B, and side C over here is opposite from angle C. That's how they match up in the equation. The other thing you're going to know is you're never going to use all three at once. Most of the time, you're just going to use two, which is fine, and I'll show you an example right here. The last thing is you need to figure out, when do I actually use this? The way that you can tell from looking at a triangle, if you're going to use sine law, the other option's cosine law, which we haven't talked about yet. The way you know when you use sine law is if there's an opposite pair. What I mean by that is, remember how we had angle A and side A, and they're kind of like across from each other, and angle B and side B? If you look at your triangle and you have one of those matching pairs, use sine law. If you don't, you probably use cosine law. This is a good example triangle because it actually doesn't look like we have a matching pair. Right now, the only side I see is right here, the 8.1, and I don't know the angle over here. So think about it for a sec. If you have 75 over here and 39 over here, basic math that we learned like in grade 8 tells us we can figure out what that is. I'm going to use the sum of the triangle angles in the triangle law. I know they add up to 180, and I'll subtract the two numbers from it. When I throw that in the calculator, it came up with 66. So I now know that this angle is 66 degrees, angle Q. That's really useful because now I have a matching pair. So I'm going to sub that into the equation that I had up here. I'm going to rewrite it so we don't have to keep scrolling like this. So I'm going to write the sine law. Sine A over A equals sine B over B. I'm going to sub in the numbers I know. That 8.1 is a side. I'm going to put it for A. So 8.1 over sine, and remember A over here will be the opposite side, 66. On the other side, I have an angle. Let's use 75 to start. Okay, and I don't know what side P is. It's the opposite, so I'm going to just call it P, so I remember which one it is in the diagram. Now what I need to do is I need to rearrange so P is isolated. So I'm going to do a little cross multiply action. So get P sine 66 equals sine 75 degrees, 8.1. Be very careful. Some students will write the 75 next to 8.1 and actually multiply that before they do the sine. Don't do that. Separate it with brackets so you remember. Then I'm going to move this to the other side and divide it out, and it's going to become this. All right, so now when I actually plug this whole thing into the calculator, I'm going to get, let me do it, I ended up getting 8.56, okay? We'll just call it close enough to 8.6. Cool. I'm going to come back. I'm going to label that on my diagram, 8.6. And now what I need to do is I need to figure out R, because most questions are going to ask you to find all the missing lengths. So to figure out R, I need to do another opposite pair. I have the side length now, so I can set that up. The thing I'm going to say to you is you should always try to use this original one that was given in the question. That way, if you made a mistake somewhere here, it doesn't compound. So, oh, sorry, these two aren't opposite. I don't know what I was thinking. We're going to do that. That's opposite. Sorry about that. So, let's set up another sine ratio. Sine A over A equals sine B over B. I'm going to sub in the numbers. So again, this side's going to look the same. Side 66 degrees over 8.1. That was that first matching pair that we had that we used. Okay, now I'm going to sub in the other numbers I don't know. So I have the sine 39 degrees and side r. Because we solved p before, now I'm going to do side r. So again, I'm going to rearrange, and I'm going to get the sine 39 degrees times 8.1 divided by sine 66. Okay, I'm going to throw that in the calculator, and we will get I got 5.579. Let's call it 5.6. So I'm going to put that back on my triangle, that 5.6. Okay, and now I've completely solved the triangle. I have all three side lengths and all three angles. I want you to know that this example triangle, we calculated sides. There will be triangles that will work the same way, where you will be given sides and not an angle. So for example, I'm just going to draw it quick. If you got like 8.2, 70 degrees, and 9.4, in this triangle, I don't have these angles. I could solve them using sine law. Oh, sorry, that one we have to do cosine law. If it was like this, let's say, there we go. So we have a matching pair. I would be able to figure out these angles by doing another matching pair and figuring it out. Okay, so when you're given three pieces of information and you have a matching pair like this, you can use sine law.